Hi guys, today we are learning about ratios and equivalent ratios. Equivalent ratios are ratios that name the same comparison. You can find the equivalent ratios by using a table or by multiplying or dividing both terms of the ratio by the same exact number. We see some examples down below. We see 2/7 and 4/14. If we multiply the top and the bottom by 2, we get 4/14 from 2/7. So on the right, 2 to 7 and 4 to 14 are equivalent ratios. Next to that, we see 8/24. If we divide both 8 and 24 by 4, we would get the ratio 2/6. So 8 to 24 and 2 to 6 are equivalent ratios. We can also identify equivalent ratios from a chart. In this chart, we see cranberry juice being compared to apple juice. We see that there are 3 parts cranberry juice to 2 parts apple juice. If we were to multiply both of those numbers by 2, we would get 6/4. That is an equivalent ratio to 3/2. If we were to multiply our original ratio, 3/2, by 3 on top and bottom, we would get 9/6. The ratio 9 to 6 and the ratio 3 to 2 are equivalent ratios. If we were to multiply our original ratio by 4 on top and bottom, we would see another equivalent ratio of 12 to 8. And if we were to multiply our original ratio 3 to 2 by 5, we would get an equivalent ratio of 15 to 10. Now let's solve some guided practice problems together. For each of our questions, we need to find the missing value using equivalent ratios. So just like we saw in the chart and in our examples on the previous slide, we will be looking to multiply or divide both the top and bottom of our ratio by the same number to find our missing value. So for question number 1, I noticed that I know both of the numbers for my denominators. So I would want to see how we got from 4 to 16. Well, 4 times 4 is 16. So then I would also multiply the top by 4 as well. And when we do, 5 times 4 would be 20. So x equals 20. So 5 to 4 is equal to, or an equivalent ratio to, 20/16. For question 2, we're looking for our value of x. And this time, I know both of my numerators. So I would want to look at my complete ratio that I know, which is 5 to 7. I would want to see how we got from 5 to 25. Well, 5 times 5 is 25, so if I multiply 7 by 5, that will give me my value of x. So x would equal 35. Five to 7 is equivalent to 25 to 35. For question 3, I know both of the values for my numerators, and I want to look for the value of x. I'm going to start with the whole ratio that I already know, 28 to 42. And I am going to figure out how we got from 28 to 4. If we divide by 7, we would get to 4. So if we divide 42 by 7, x would equal 6. So 28 to 42 is equivalent to 4 to 6. For question 4, again, we want to know the value of x. And I know my whole ratio that's already filled in for me is 3 to 8. So I would want to start there and figure out how we got from 8 to 64. If we multiply by 8, 8 times 8 is 64. So then 3 times 8 would tell us our value of x. So 3 times 8 is 24. Our value of x is 24. So 3 to 8 is equivalent to 24 to 64. For question 5, we're looking for our value of x. We'll start with our ratio amount that we already know. So I want to figure out how to get from 9 to 45. Well, 9 times 5 is 45. So if we multiply 7 by 5, our value of x would be 35. 9 to 7 is equivalent to 45 to 35. And our last question, we want to find the value of x. We'll start with the ratio that we already know, 17 to 45. And I want to figure out how to get from 17 to 34. If we multiply 17 times 2, we would get 34. So 45 times 2 will tell us our value of x, and x equals 90. So 17 to 45 is an equivalent ratio to 34 to 90. This time we will be finding equivalent ratios by filling in the chart provided. We have potatoes to tomatoes. So there are 2 potatoes to 3 tomatoes. That is our original ratio. And then each time we will be finding an equivalent ratio to that. So to get from 2 to 4 for the potatoes, we multiplied by 2. To get from 3 to 6, we also multiplied by 2. So our equivalent ratio is 4 to 6. So then we move down to 6 for the potatoes. And we think, how did we get from 2 to 6? We multiplied by 3. So if we multiply 3, our original amount for our tomatoes, by 3, then we would get 9. So 6 to 9 would be equivalent to 2 to 3. And last we see 8 for the potatoes. So to get from 2 to 8, we multiplied by 4. So we could multiply 3 by 4, and we would get 12. So 8 to 12 is equivalent to 2 to 3. So how do we know if the ratios that we see are equivalent ratios? They must be multiplied or divided by the same number in order to be equivalent. So we could know if they are equivalent if they can be multiplied or divided by the same number. So with our questions down below, let's determine if the two ratios we see are equivalent ratios. I'll start with my numerators for each one. So I think about how I got from 4 to 16. We multiplied by 4. So then I would also need to multiply by 4 for my denominators. Well, 8 times 4 is 32, not 20. So these are not equivalent ratios. For question 2, how did we get from 9 to 27? We can multiply 9 times 3 to get to 27. So if we multiply the 10 down below by the same 3, 10 times 3 is 30, and 30 is the denominator for the second ratio. So these are equivalent ratios. For question 3, how do we get from 7 to 28? We can multiply 7 times 4 to get to 28. So then we would also need to multiply 5 times 4. 5 times 4 is 20, not the 30 we see. So these ratios are not equivalent. And for question number 4, we see 36. How do we get from 36 to 9? If we divide 36 by 4, we would get 9. So then we would also want to divide 16 by 4. And when we do, it equals 4. So these two ratios are equivalent. Now you will work on 2 independent practices on your own. For both independent practices, you will be finding equivalent ratios and writing ratios and equivalent ratios. Remember to ask for help if you have questions, as this is a new concept for us.